Hey everybody, welcome to the tutorial for using R and RStudio for the data analysis. Um, this is going to be, as basic of an intro as we can do, just give you enough to be able to to do the analysis here. We're going to be a little bit limited both in terms of in QM, there's only a limited amount of stats that you learn. So I've kind of had to tailor everything towards kind of stats that you already know. So there's kind of some things that we just aren't able to do. And also just I'm trying to keep the, particularly because we're not having in-person labs, trying to keep the code as simple as possible. So there's in many cases other or even better ways that we could do some of the things I'm going to show you, but they would require more advanced coding or installation of additional packages. And I just want to avoid as much confusion as possible. So we're going to just keep it as simple as possible. What I'm going to give you, a lot of what I'm going to show you at first will look complicated, particularly if you've never seen coding before. Some of it's going to look like a foreign language or an alien language. But it's once we go through it together, you'll see that it's really not so difficult. I've tried to kind of come up with every possible scenario that you could come up with your questions and the type of analysis you'd want to be doing. So I've tried to essentially write an example of each type of code you could possibly need. And so all you'd really need to do is copy and paste the code and change kind of the survey name, because I'm using kind of a mock survey that I created in Google Forms, just kind of a real basic one that I ran myself about 8 times and had just a few questions. And so all you'd have to kind of do is change the survey name and the variable name. So let's just kind of start. So this is what you'd get the first time you launch RStudio. It's this kind of first screen that you'd see, and so you'll have 3 windows. This here is kind of your output / kind of command line. So anytime you run a command, you'll see the output here. So that's going to be important. You can also just write a command in here to do it. Like say I wanted to know what 2 + 2 is. I could write it in here and do it. There we go. And so we see 2 + 2 is equal to 4. And so we could do that right here. We're not going to rank most of our commands here, and I'll describe why once we see another one of the panels. But we're not usually going to do it, but you are always going to see your output in this screen. Over here, so we don't have any data loaded right now, but once we load in, we either save some variables, or once you load your survey, kind of any surveys or objects that you've saved get listed here. So once again, we import some stuff, this will make more sense, but this is kind of like everything that you've got loaded. So you want to make sure that your survey is loaded in here, and it's also going to give you a little bit of details. This is kind of your help screen. If you want to find kind of any details or any kind of like guide on any of the different commands that you're going to be using, you can get details here. So that's useful. And also anytime you make a graph, it'll show up here, and you can cycle through the different graphs, and you can export them also. So you can export them as an image or as a PDF. So to be able to copy them into your paper. So that's this is a really useful panel too, and to show the help, say, just as a preview, we'll come to it later, but say you want to be finding the mean, or like the average, right? And so the command name for doing that is, well, simply mean, and we'll take a look at it later. But say I know it's mean, but I don't quite remember how I put everything in there, or what are the different options you can have with it. If I type ? And that command, I get the help file for doing the mean. So it tells me, this is for doing the mean, a description and how you'd put in the details, everything, all the different options, and often kind of an example down below. So that's certainly useful. Also, all of these things, because R is open source, So anybody can contribute packages. It also means that a lot of people are really invested in making it accessible to a lot of people. So there's really, really good online help. So pretty much any problem that you can also mail me about any problem you have, but also pretty much any problem you're going to encounter while running these things. Many, many, many other people will have run into this problem. And so you could kind of just Google the error message or the problem you're having, and you're going to find like a lot of different web pages with solutions. And that's one of the really good things is when you're working on a project, you're always going to run into new errors. Hopefully for you guys, there'll be as few as possible because we're doing relatively simple things, and I've hopefully tried to come up with as many ways of avoiding problems. But if you do run into them, there's always and that's normal to run into problems. You can always find it with kind of a Google search. I didn't actually learn later in my kind of student or grad school career. I took classes where we used R, but I actually started using R before I ever took it in a class, and so kind of self-taught. So particularly in those cases, the online, just being able to Google the problems I'm having was invaluable. There's also a lot of tutorials and stuff like that, but you shouldn't need much of that because I've tried to be as exhaustive as possible. Now there's a fourth panel, and this is the panel that you're going to do the most of your work in. And so in your case, you do File, New, R script, and you'll get a panel up here. And this is where you're going to write the bulk of your commands, right? So say I want to be doing 2 plus 2, right? I would write it here. Now, if I hit enter, see, nothing's going to get calculated, right? There's no 4 appearing down here. If I want to have it get calculated, I would highlight and hit run. You can also do it as control enter, right? And now I see 2 plus 2 down here is equal to 4. So why do you do it here as opposed to down here to write your commands? The reason is that, so every time you close R, everything that appears down here disappears. But the things you do up here, you can save, right? So you can save essentially a template. Say you're not going to be able to finish the whole project in one day, or you think you're going to have to come back, or you want to be able to send it for another member of your team to work on. Like, and if you started one part and they're supposed to be working on the next part, you can save this as a file, right? That then they can load. So if I hit, see now because I wrote something, I can hit this, right? If I hit this, it'll come up with like kind of dialogue. Where do I want to save it? And then I can save this as an R file and then reopen and can continue. So that's why it's kind of called a script file. So it writes in everything you want to do. So I can write out kind of a series of things I want to do in sequence, and then say highlight all the different lines and run them, and then look at the output. So because it's reproducible, so just in terms of, for good science, we want other people to be able to see what we did. So in terms of good science, it's reproducible. We can share other people. We can share our script with other people. Some journals now, if you want to publish, you have to kind of share a script or a kind of a file, a do file, depending on, or R script, depending on which stat software you're using, so that other people can check your work. Essentially, if you give them your original data, you give them essentially your script of everything you did, they can repeat it and see, did they get the same thing, or were you just making stuff up? But also just for yourself, oftentimes the project's not done in one day. So in terms of just being able to, kind of continue working on it, saving it, being able to save what you do is great. And now, so the results each time you close R will go away. You just run your script again and everything will appear. And all the stuff that you're doing, the calculation time is not even noticeable. There are certain, if you're working with a big enough data set and running advanced enough stats, sometimes it can take. I've run certain kind of predictive type modeling with huge data sets that could take hours to run, but that's because it's involving millions and millions of calculations, where everything we're doing here will be run, will take less than a second to execute. So rerunning your entire thing will go super quickly. Okay, so you would start with kind of a new script. I'm just going to open, you can also open one. So if you want to import, say, the one that I'm going to be sending you this tutorial, you could also just, if you've got RStudio installed, you could just also open it kind of in a file and like in a folder, double click it and it'll open in RStudio. So I'm just going to open kind of the tutorial. And I'm going to go to my recent files. All right, let's go up to the top. So again, it's going to look scary, but once you get used to it, you're going to see it's not so scary, because a lot of it's just going to be take what I did, copy, paste. So notes on the results and analysis. So kind of there's three parts of the results and analysis section you're going to need. And this is kind of from the data perspective. So obviously you're going to also need some discussion. So you're going to need some analysis. But you're also going to need just kind of like to run some numbers to get some results. And there's kind of three portions you're going to need. So first you're going to need, and this is going to be brief, but you're still going to need to talk about it, is you're going to have to talk a little bit about your sample. So this is where the demographics usually comes in, your demographic questions. So you're going to want to talk about your sample size, and so you can either count and see how many respondents you had, but you can also, there's commands in here that'll tell you how many observations you have, so how many respondents you have. But you're also going to want to talk about, what is the average age, what's the gender breakdown, what's the racial breakdown, stuff like that, just so we can understand for the demographic question you asked a little bit about kind of your sample. And so you're going to want to have a brief section where you talk through your sample. And in the paper, you're going to want to include descriptive statistics. And you can include any graphs that you do for your descriptive statistics. You can put that in appendices. We don't want to take up the whole paper with graphs, but definitely include at least a brief section that gives the basic statistics of your sample. You're going to want to include details about your independent and dependent variables. So forget about first looking at relations. You're going to want to tell me just a little bit for the questions that you asked for your kind of independent variables and the question you asked for your dependent variable. Just give me a little bit of stats in terms of what are the answers that people gave. So essentially the descriptive statistics for those questions, right? Say it was a 5-point scale of agree to strongly agree to strongly disagree. What percentage of people said strongly agree? What percentage of people said agree? What percentage of people said neither agree nor disagree? So on and so forth. So for the kind of the different questions that are important for your analysis that you think either explain your problem or that are used to measure your problem, just give some descriptive stats. And then third, and most important kind of for your actual paper, look for your hypothesized relationship. And so this is where what we call inferential statistics come in. And so this is where the stats where we're looking for relationships between more than one variable. And in this case, you want to include both the statistics and the graphs in the paper, because this is of core importance, and there won't be as many, but this is also of core importance for your analysis. And then the third part here will be, and the C, but you're not going to run this in R. This is just going to be each of you doing individually would be kind of an analysis, right? Analysis of, do these relationships fit what you expected? Is there a relationship, and does it fit what you expected? And so we're going to kind of go through these kind of, first we'll look at descriptive stats, because it doesn't really matter in terms of how you do it, whether it's demographics, independent or dependent variables. So we're going to look first at that, and then we're going to look at inferential statistics. But before we do that, I want to start just with basics, right? Because some of you took a QM with me, so we'll have some basic familiarity with R, but most of you didn't. Kind of just a real basics, kind of just only the things that you need to do to be able to do this analysis. So there's a lot of things even that we did in QM, or if we had more time, if we had multiple labs, if we had a full semester, like if this were in the fall, that we would normally learn, that I'm just not going to include here because you don't need to do it. And right now, I just want to kind of minimize confusion. Is kind of primary goal here. So the first thing in terms of R basics that we should note is called commenting. So you're going to notice I've included a whole bunch of pound signs or hashtags on these lines, and a lot of the text is green. Everything to the right of a hashtag in a line will not be read. So it'll be, the text will turn to green, and it won't be read as kind of executable code by R. So essentially R will skip over any text in green. So anything to the right of a hashtag in a line. So why would you want that? So you want that for a few purposes. So it could be that you want it, so here, how I'm using it to kind of separate sections, right? So I've got kind of big thing for saying this is the start of a big section, and then, 3 for commenting, and then kind of just 1 for less important. So kind of like the more different hashtags I kind of use for meaning kind of like importance of section headings. So you can use it for dividing sections. You could kind of divide it so, and then with kind of text about what you want to be doing, right? So say you were doing kind of exercises, right? You might do question 1, right? And so you're commenting an entire line to say what's coming below is all the code I need to answer question 1. And then I could have another one, question 2, everything I need for question 2. So in your case, you could do variable 1, like race variable, right? If you want to be doing the descriptive stats, you could have a big descriptive statistics, right? Or demographics, right? And then you've got kind of your race 1, and so you'd have race, and then you do your stats for race. And then the next one might be age, and then you do your stats for age, right? So everything's kind of nicely organized, you know where it is. You also sometimes might put it at the end of a line, so say I've got this calculation here, and if I just look at this calculation, I might be wondering what the heck is this calculation, right? So I can put a comment at the end saying, hey, I'm averaging scores from test 1 and test 2 here, right? I could also use mean to do that, but you can do it like this. So average scores from test 1 and test 2. So I can add kind of just a comment to say this is exactly what I was doing on this line. So say this is particularly useful, say if answering question 1 takes multiple steps, right? So I could have step 1 with a comment here, step 2 with a comment, same way I'm doing in each of the different steps. So commenting is really important for multiple reasons. So for structuring your code, your script, like I said, so kind of having different section headings so that you could remember what you're doing. So that you can, like, for example, say, you start it today and then you come back another day, right? Sometimes, or, there's sometimes been, I've started a project and then I get distracted. Like I start a project in the summer because I don't have much teaching, and then it comes to the fall and teaching starts up, so I don't have much time to work on it. So 3 months might go past before I come back to working on it. When I come back 3 months later, I'm not going to remember everything I was doing. Why was I putting this code here? What was I trying to do with this code? Where if I put in comments, it reminds me of exactly what I was trying to do. And particularly when you're newer, that with using R, that's really important. And also it lets others do it, see what you're doing. So if you're reading someone else's code because you want to be looking at their project, right? There's so many different ways of doing different things in R. So, it's really useful if you're coming in that you can see kind of a description. Oh, this is what they're trying to do here. This is why they're doing this. This is what this code's trying to accomplish. And so this way you can kind of come in and understand what others are doing. It's also really important in your context, right? Because you're working in groups. So if, you could also all kind of like conference together and work on, somebody shares their screen and work on it all at the same time. That's definitely one way of doing it. Another possible way of doing it is, one person does one part, another person does another part. I leave that up to you. But particularly if you're doing that, right, you're going to want to have a lot of comments so that the next person who comes in knows what you've done, how you've done it, why you've done it, so that they can then see, okay, where exactly do I continue? What's been done? What have you been naming things? So commenting is really important for that. Okay, arithmetic, so just the real basics of R. And actually, I just want to show you something. See, so if I run these 2 lines, right? So this will just print, but it's not trying to run and find out, question one, what does that mean? And then here, see, it just gives you the output, right? So it ran kind of this equation, but it didn't think, all of this text was part of that equation, get confused with an error message saying, what does divided by 2 hashtag averaging mean, right? Like, what is 2 hashtag averaging in terms of stats, right? And it didn't run into that problem because it hit the hashtag, it just stops reading. It'll just print it, but it stops reading. So it just runs kind of that average. So arithmetic, you're not actually going to have to be doing very much of this, but it's still useful to know. So if you need to be doing addition, subtraction, multiplication, division, an exponent, there's 2 different ways of doing exponents. Square root or absolute value. These are the different ways of doing it. So for example, if I run all of this, I know Control Enter would be more efficient, but I should just always still hit the run button. Usually with R, you try to be as efficient as possible, but some of it also just comes down to habit. I still use some commands that aren't the fastest way of doing it, but I've become comfortable with it. And so I use it just because of my own comfort. So here, see, it runs all the different commands. So 1 plus 1, or sorry, 1 plus 2, 3 minus 2, so on and so forth. And so that would be the outputs. So far, when we've done this math, we've kind of just had the outputs reprinted, but sometimes we want to save kind of the output of a calculation into a variable, or kind of save it for future use. Oftentimes in calculation, you've got to take the output of one and then put it into another equation. So you might just want to kind of save it so that it remembers it to be able to use it. If you're using a calculator, sometimes you've got to write down a number after one equation to remember to put it into the next one. Here, you don't have to write it down because you can save it. But also sometimes you're going to want to be saving things in variables. So for example, say I want to be remembering what 2 plus 4 is, right? Because I'm going to be needing to use it later. I can assign it to the letter A, like this. So see here, when I do this, it doesn't print what 2 plus 4 is, right? Because I'm not asking it what 2 plus 4 is. I'm asking it to assign, and we use this arrow. You could use an equal, but equal can run into some confusions. So I like just using the arrow. And so here we're just assigning it to A. So then if we want to see what 2 plus 4 is equal to, we can either, and the easiest would be just type A and hit enter, or hit run, right? So if I just hit do A, then it shows me what 2 plus 4 is. Or I could do print A, which is a little bit less efficient, but you could still do it. In certain circumstances, it'll have advantages. So this way you could save it to use it later. So for example, say here, I want to be using it later, and I want to see what's 2 plus whatever A had been, right? Say, for example, we've got all of your different scores on a test, and I decide, oh, you deserve a bonus because the test was a little bit too hard, right? So I want to add 2 to everybody's score. Rather than writing in everybody's score, I could say the score in a variable A, or the series of scores in a variable A, and say just add 2 to it. And I could save that in a variable B, or I could just print it, right? I could also do, rather than saving in B, I could do 2 plus A. And I'll get it. But I could also assign it to a variable B. And then I could print B. And I get A. 8, sorry. Also, just to remember, so let's print A again. You can change the assignment of these variables. So for example, and I actually just want to point you over here, right? So here, kind of I said any variables, data sets, or values that you save will appear kind of in this window over here. So here we see we've created an A and we've created a B, and it shows the values. Now I want you to look. So A right now is showing 6. Now if I do A is equal to 3 times 4, hit run, And now let's print A again. So printing at 12, and we see over here, it's 12. So when you save something as into a value or a variable, you can write over it. So be careful with that. So don't create kind of use the same. If you've used A once in it and you still need to be keeping it, don't use A again, because if you do, you'll be writing over your old one. So just keep track of that. But it also means that, say you made a mistake, right? A wasn't supposed to be 2 plus 4. It was supposed to be 3 times 4, right? You made a mistake when you wrote it the first time. You don't have to delete A. You could just kind of write over it. So you can assign a new value to it, and that'll replace the old one. All right, so data frames and variables. So far we've just got some values, so a couple of kind of assigning to kind of numbers to values. You can think of these also as variables because they can take on different numbers. But we're going to be dealing a lot with variables and data frames when you're dealing with surveys. So just want to this over. So want to read through a little bit of data frames. We haven't loaded any data frames yet, but we will in a second. And so I just kind of want to talk through a little bit of the what it means and how we're going to work with it. So most of the time you'll be dealing with data that's in the form of a data frame. Think of a data frame as a table of data. That's literally what it is. Well, when we load one in, we'll take a look and it'll just look like kind of a table data. Think of it as like an Excel sheet of data almost. So for example, if you import your entire survey results as a table, so if you import like when you do Google Forms, you can export it to a CSV file, which can be opened, say, in Excel. And you'll have all your questions in columns, and you'll have kind of each different respondent get a row with kind of their responses to each different question. If you import that into R, it's called the data frame. And so you'll get the data frame listed over here. And so whenever we say data frame, we're talking about kind of, in this case, we're talking about your entire survey. So all the questions and all the responses in a table form. That's the data frame. When we talk about variable, we're talking about a question, right? So think about like you asked, how old are you? We could call that the age variable. And so that might be called age. And so when we talk about, that variable, we're pointing to a specific question. So if we say the age variable, we're pointing to the question, how old are you? If we say the gender variable, we might be talking about the question, what is your gender? And so each of your different questions would have a variable name. So when you import your data frame, you give it a name. You give it a name for example, you could use things like my data, my survey, which isn't that creative. I'm using something similar for kind of today's tutorial. I don't suggest using it, because eventually you'll just end up with a lot of those and it could end up being confusing if you've got 2 projects, both with my data name, but also because it doesn't really tell you much about it. So for example, if your study's about race, you might call it race study, or you might, or race survey, right? So that at least you understand a little bit, kind of the name of the data frame is telling you a little bit about what's in it. But if you just want to call it my data or whatever you want to call it, that's fine. If you just want to call it survey, that's fine. Whatever you want to call it, that's okay. Just a few things when giving it a name, it's important that it not include a space. So you see, I used a underscore between different words. I also could have just, done this and had no space and had my data as kind of one word. But you don't want to have a space because it's not going to know what to do with that space, or any mathematical operator. So you don't want a plus, a minus, kind of the multiplication sign, so it's like a star, or a slash for division. You don't want to have any of those in there. So separating words, there's a few things that people do, right? So I like the underscore. It's kind of what I use the most, but there's some will use, say, my dot data. Some will just do my data. Some people do my data. So at least you could kind of see the different words based on capitalization. There's a lot of different forms of how you can do it. I most frequently personally use underscores, but that's just kind of what I got used to. Whichever you want to use is fine. And also try not to make it too long. So in pretty much everything you do, almost every command you're going to write, you're going to have to write the survey name. So if you write like, if you give it a title of like my survey about race, or about say hours of sleep and academic performance, right? Super detailed. And a group has something I think similar to this for study. That's why I went with it. But I mean, super informative, right? You certainly would be, clear of what this study is about. You won't get it confused with another one, right? But if each line of code I have to write this, and sometimes you're gonna have to write more than twice. It's just not very efficient to write something that long, right? So you might do like instead like sleep perform, right? Still tells you something about the study or, sleep school. Something like that, that like still lets you understand, kind of point to what the survey is. Right, I had one on trust, a survey that I did on trust, and I called the entire data frame TR, for short for trust. And this way it was, because it ended up being, it was a big study, so it was a couple thousand lines of code. So if I had to write something really long each time, it would suck. But if I was just writing TR each time, it saves you it ends up over the long haul saving you a lot of time. So often you'll want to be using just one variable, right? So a survey question. So say you want to be finding kind of the average for race, or not the average, but or average for age, right? When you're doing your demographics, or the kind of percentage for race in terms of demographics, right? So you're going to want to be pointing to one variable or one question at a time. So there are multiple ways to identify which variable you want to use, but the most common is by separating the name of the data frame from the name of a variable with a $sign. So for example, data frame name, so say I'd call the data frame name my data frame, right? $sign variable name. So you could call it like my data $sign age. Why is it important to have kind of the name of the data frame? So sometimes you'll have more than one, say, project open, right? So sometimes I'll have more than one survey open at the same time, particularly because I'll often cheat off my own code, right? So I've got two surveys open, and both of them have a gender question. Both of them have a race question, right? So say I then just run the command for race. I just point the variable race. R doesn't know, am I looking in project 1 or am I looking in project 2 to find race, right? Because there's more than one variable. I doesn't know, am I looking in project 1 or project 2 for gender. So we include the data frame name so that R knows, okay, look for the variable race in this data frame. Look for the variable, hours of sleep in this data frame. So it's telling R where to look. So if you just write the variable name without the data frame, you're usually getting an error because R just doesn't know where to look. So that's kind of important. So just remember, you're going to see a lot of this. And to be honest, this is going to be kind of the format that you're using the most frequently in terms of your study. This is going to be the single thing you write the most often. Because, I mean, if once you get it kind of into your study, you're going to be copying and pasting this a lot. Because most of the code, so most of the commands that you're going to need, I'm going to be giving you in the tutorial below. The thing I can't give you is your variable name and your data frame name, because I don't have your data. I don't know what questions you're going to be needing. I don't know what tests you're going to be needing. I don't know what you're calling your data frame, right? So that you're going to have to be doing. So say, for example, you want to be finding the mean. I'm going to give you what the command for mean is, right? But you're going to have to say the mean for which variable in which data frame. So say I give you, so just as kind of a preview, mean is, right, data variable, right? So I'm going to give you kind of this type format, but you're going to have to replace, you're going to have to insert what is the variable name and what is the data frame name. And then you'd be able to find the mean. So a lot of it's going to end up coming down to copy pasting. And you notice whenever I make a change, I go right to save just in case something crashes. Good habit to get into. I'm going to give you, say, the mean command, and which you're going to be using several times. But you're just then going to have to kind of take that for each of the variables where you need to find the mean, put it down and so do like, age, and you can even comment like a section, age, mean, data, age. Right? If I ran this, I don't have a data set called data right now. So if I ran this, I'd get an error because error in data age. So it doesn't know what I'm doing here. So you'd get different errors. Unfortunately, sometimes the errors aren't terribly easy to understand what they're saying. But in this case, because it doesn't know what this means. I don't have anything loaded here called data. So it doesn't know where to find age. And then you might do it with a different variable and still have it. So you just then be able to keep the same data frame name, but just update the different variable. Let's say it was like hours of sleep. Right, then you do mean data hours. Say you call the variable hours sleep. And so just by having kind of that mean and then kind of what the format should be, all you've just got to be doing is then putting in your data frame name, your variable name, data frame name, variable name, data frame name, variable name, which makes it really easy. All right. So setup. Unfortunately, this is an area that often leads to some confusion. Actually, kind of before. Okay, so let's take a first look at this step. So setting working directory for the project. So this tells R where to look for files that you open or where to save files. So for example, if I want to be loading, the sample data, I don't want to be writing in the full path each time I'm loading something. So I can tell R, this is my project folder. And same thing, if I save anything, right, I'm telling R, save it into this folder. So I don't have to be writing in the full path. So you'd write kind of in your folder path. And like this. So mine is in users. So this you can't straight copy paste because this is the path for my computer where I'm saving what I'm doing here. So I've got in a folder called R tutorial in my summer 2020 IM folder, which is in my Champlain College folder, which is in my documents folder, which is in my personal folder in C users. To get this, so if you're in a Windows, give me a second. If you want to get this, right, in Windows, you can just go to, well, if you click on it like that, you could just copy and paste this. You could copy paste this. Otherwise, you can also right click, copy address as text, and it'll do the same thing. But also if you click on it, it'll come to copyable. Now I want to just show you something quickly. So there's one thing when you copy paste it in that you need to do is you'll see that the slashes are like in this direction, right? And you're seeing an unexpected error on each of those different slashes. In R, so Windows uses kind of a backslash. In R, you use forward slashes. So when you copy and paste it in, just change all of the backslashes to forward slashes. There we go. And now that would work. The other thing, so that's the easy way of getting it. So you copy paste it in, and you always will want to, every time you're kind of dealing with kind of characters that aren't a command, you've got to put it in quotes. Otherwise, it's going to think it's a command, right? So if it's a command name, it's not in quotes. So this is called set working directory. So working directory, again, is kind of the folder you're using for the project, right? But this isn't a command. This is the name of the folder, and I want it to read it as kind of a series of text. So you put it in quotes. So in this case, if you want to be copying yours in, you could just kind of select here, copy paste it between the quotes, and then just remember to change the slashes around. I'm not a Mac user, so I don't know so well how Mac, kind of how to get the folder names for Mac, but it'd be the similar principle. All right, so then we've got to load in your survey, right? And so in Google Forms, one of the options when you go to response is export as CSV. And CSVs you can load in Excel. Also, it just means comma separated. So kind of each different cell is separated by a comment, which isn't terribly important. It's just kind of in terms of how the file's saved. And so there's two ways you can do it. So once you've set your working directory, you can use the read CSV command, right? And then you just write in your data file name. So I saved the file as called sample data, and it's a CSV file. So the name would be sample_data.csv. You're going to name, I wouldn't name my survey sample data because it's not sample. Well, I suppose it is technically a sample, but like whatever you name your survey, you put this name in. Header equals true. This is important because it tells R that the first row are variable names or are names, right? So don't treat it as the same as the other. So it tells it essentially start looking at the data as row 2, treat row 1 as variable names. So header is equal to true, or you could also write TRUE for the full true. That's fine. And so in all your cases, header is equal to true will be the case. So you'll never need header equals false. I believe it actually defaults to header is equal to true, so you probably don't even need this, but just I always still just put it. And so in this case, and so once you do this, so read CSV this, and you've got to give it a name. So this is, remember where I said you'll have a data frame name, so it could be my data, it could be, so all the things we looked at here, right? My data, my survey, race study, something like that. This is where you give it that name. So in this, for this tutorial, I'm calling it sample data. You can, again, call it whatever the heck you want, but this is going to be that part, remember where we looked at kind of data frame name that comes before the $sign. This is where you're setting what that before the $sign thing is going to be. And so this is telling to look in this folder, right? Because we set that as a working directory for this file. And I just quickly, oh, that's a problem. Sorry, I forgot to, I'm gonna have to re-explain that because I forgot to change my sharing screen back, which was silly, but I don't quite, why are you not highlighted? Okay, there we go. Sorry about that. Okay, sorry, I'm gonna have to repeat kind of what I had said there before because, as you probably noticed, I was still showing the folder. I forgot to switch back my sharing screen. So what I've been talking about, so when you copy paste in the file name, you can, so you'd copy it in here and you'd be changing all of these slashes to forward slashes, right? So that's when I was talking about the forward slashes versus backslashes. When you put kind of the folder name in here, you want to make sure all the backslashes get changed to forward slashes. When I talked about kind of putting everything in quotes, this is what I meant. So the file folder name needs to be in quotes. Otherwise, you're going to get an error message if it's not in quotes, because it's not going to know what command C users mark P documents. It's not going to know what that command is. So because it's not a command and it's kind of a string of characters, you've got to put it in quotes. So this is, and this is what I was talking about, where it's going to be different for each of your computers, right? Because you're going to have different kind of file path names. Here's where, when I was talking about kind of the read CSV, so this is the read CSV, header equals true, saying the first row is variable title names. Sample data CSV is the name of the data file that I had. So that's so this is where kind of I saved my survey results. You will probably have a different data kind of file name. That's okay. Just change list or whatever. Like, you know, it could be I am survey. That would be fine, right? Whatever it is, it doesn't really matter. So whatever it is, it doesn't really matter. Just it's got to be consistent with your file, and you don't have to put the full path because you've set your working directory, so it knows to look here to find this. And this is where I talked about the you've got to give it the name, right? So sample data is the name that's going to come before the dollar sign. So in kind of the data frame variable name thing, this is going to come data frame. That data frame part, data frame name is whatever you put here. So it's important to have this here so that you're actually giving it a name. There's another way of doing it too. If you're having trouble getting this to work, or if you have trouble kind of understanding what to write here, you can also use sample data. So this part, read CSV file.choose, and this was and header equals true. Once you run this command, it's going to get a, okay, let's just run it. I'll show you. It's going to get a pop-up to come up. Mine doesn't seem to be working, kind of annoying. But I'll have a pop-up come up. Where the heck is it? Oh, sorry. I'm not sure. It's unfortunately with sharing screen, it's not gonna pop up for you to see. Like it won't be shareable, but there'll be a pop-up window like your normal kind of dialog box for selecting your file. So if you use that, you'll be able to kind of just go into your folders and find it. So this particular, if you're having trouble with set working directory, if that's just not working for you, which is okay. I know some people sometimes have trouble figuring out how to do this. If that's not working, right, then if you use file choose, you'll be able to point into your different kind of directories, go through, find your folder that you want, and load the file you want. So select it yourself. So if you're having trouble with set working directory, if you're having trouble getting this to go, use this instead, and that's fine. And so it'll let you search for the file, kind of in the normal way that you'd open files through your menus. And so that's fine if you want to do it. Okay, what I meant to be switching over before, sorry about that mistake and making this video a little bit longer. What I'd wanted to show you was, so before we load the data, I just wanted to show you, okay, so this is the data. So it's a kind of a silly survey that I made, and then the results are meaningless. I just went through it like 8 times and randomly made sure that I selected each different answer a couple times so that we ended up. So you always get a timestamp. This isn't important. You don't have to look at it. You can even delete it if you want, but it doesn't really matter because you can import it and it's not going to cause you any problems. And then, so the question was, do you agree? How old are you? What is your race? And is this good? And this one was kind of a 5-point, strongly disagree to agree. Strongly disagree, sorry, to strongly agree. How old are you? They could write in their age. Race, they had a selection of, I think I did black, white, other, just because, you know, it's not a real survey. And is this good? Yes, no. Just to try to get questions of different, so kind of like having some that are nominal, ordinal, and interval/ratio type thing, so that we had kind of a selection so we could look at how to do different stats. But this is the way that's going to come out, right? So whatever your question wording was is going to be up here, which is actually a little bit annoying. Well, it is good in terms of it lets you see what the question is. It's a little bit annoying that, you know, these aren't great variable names, particularly if you've got long questions. These aren't great variable names. Also, every text one's going to come out with the full text response. So, you know, that's good, but also a little bit annoying too. It's not my favorite feature of Google Forms. There may be a way around it, but it's definitely not my favorite feature. So this is what, like, when you export your data, you're going to have a lot more, and you're going to have a lot more questions out this way. So all the questions, like I said, are going to be different columns. And so these will come in as your variables. And each different respondent will have their own row. So this is what essentially we want to be. So I've opened in Excel, but still a CSV, because you can export as a CSV. So you can save this when you export it into kind of a file, and that's what you're going to be bringing into R. All right. So now let's go back to sharing our studio. Good, I remember it this time. All right. So now let's just import the data. Well, I can run all of this in matter. Oops. Sorry, I never actually ran my working directory command. Now we can run this. And you'll see now we've got a sample data, 8 observations, so 8 people took it, 5 variables. So there are 5 different questions, well, 4 questions in the timestamp. And if you double click on it, you'll get to see kind of the table of data. So this is the data frame, right? It's your survey, the questions and the responses to each of them. And so that data, so this entire survey is saved in kind of a data frame called sample data. So it's kind of like the name of the file. But it doesn't have to be the same as the name of the file, but we just named kind of the entire survey something to tell our, if, you know, look inside, if I'm talking about like, how old are you, look inside here. Now you're going to notice for variable names, it's got periods between each of them, right? Because you're not allowed to have spaces in variable names. So it's gone and put periods in there. And so particularly if you have long questions, and this is something we're going to look at, we may need to rename some of these, right? For particularly if you're making plots, but also just like, say you've got a, you know, 50-word question and you want to be doing analysis on it. You don't want a 50-word to have to be writing, you know, do you agree with the following statement, blah, 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 blah. And you don't want to have to be writing that full thing in when you're doing kind of your analysis for each kind of question. That would get annoying. All right. So the first thing you want to do when you import, so now we've got it over here. So the first thing you want to do when you import is inspect your data. So you could click and go on to the, you know, the table like we did, but typically I run a couple of other commands. So let's actually do this one first. So the first is head and name of your data frame. This by default prints the first 6 lines of your results of the data. So prints all the variables with the first 6 results, just so you can kind of see what are the, you know, what format is it. Like, for example, did I assign numbers to race, or do I like as coding, or do I have it just in terms of words? So what does my data look like? You can have it longer if you want. If 6 isn't enough, you could say change it to 10, which won't work for us because I only have 8. So I could do 8. But this way, it lets you kind of inspect the data without, you could have a data frame sometimes with like a million observations. You don't want to be printing all that down here. So this still lets you kind of inspect it. The other is called STR. This is really useful. So if we look below, if we look below, it gives you all the different variable names. And you can see it's even got the $ before, so kind of showing you your normal format, right? So it's got the 8 observations, 5 variables, got each of the variables. It tells us what type of data. So factor, you're going to have if it's anything character related. So, black, white, other for race, strongly disagree. So if it's nominal or ordinal, it's going to come in as factor. So anytime there's kind of words, sometimes numbers too. Sometimes you're going to want, say it's Jersey numbers, you're going to want to be treating it as character. So that still could be factor. And then usually if it's numbers, you're going to get it as integer or numeric, NUM for numeric or integer. If it's just numbers without decimal, it'll be in integer form. So this lets you kind of see how is it treating your different data. This is also important for, like, for example, say you wanted age to be like, say it was Jersey numbers or telephone numbers, right? You wouldn't want it being treated as integer, right? So if you loaded kind of, say this was telephone number instead, and you loaded and you saw, oh, it's being treated as integer, we need to change this, right? Because I don't want it being treated as numbers. I want it being treated as characters, right? Because the numbers aren't meaningless. I don't want to be able to take the mean of it or something like that, because the numbers are meaningless. So I know I need to change it over to factor at some point. Or sometimes you'll load in numbers and it's going to think it's factor, right? It's going to think that it's kind of like telephone number or Jersey number, but you really want it being treated as numbers. So if you see a variable, how old are you? And if you see factor, right? Well, you've got to change this, right? It might have been somebody wrote, 18 years. And so you're going to want to go into the original data and get rid of the years. You could also do that in R, but I'll let you just do that in Excel if you want, because that's why it's being treated as factor, because somebody wrote words, so it can't be treated as number. So those are the 2 things you want to start with in terms of inspecting your data frame. These are 2 commands. Every time I open a new data frame, I take a look at my data using that, just to kind of get an idea of what am I working with. And so that's kind of the real basics. So now we're going to get into data preparation and descriptive stats. So you're going to be running descriptive stats for all your demographics, but also for your kind of your IV, DV type questions. So first we can learn more about our data frame. And so these are a series of commands that are useful in kind of giving you some information. And some will be useful in terms of your kind of descriptive stats. So if you want to be, for example, talking about your how many people answered your survey, right? N row is actually really useful for that. So number of rows, 8. So length you can use, and that'll give you the number of, so this isn't a commonly used one in data frames, but it'll tell you how many different variables are there. N row will tell you how many different observations there are. N column will show you also the number of variables, similar to length, but N col would be a better one. Dim is nice. It shows you dimensions, so it'll show you number of rows, number of columns. Names gives you the list of variable names. So this is really useful if you want to be looking, okay, what are the different variable names? And what do I need to be changing them to? STR will do this also, but if you don't want all the other stuff and you want to be saying, okay, right now I need to be changing these names to something that's more useful. Let's get them all printed so I know what to change, which ones need to be changes. Row names, So this isn't as useful because usually this could be numbers. Call names does a similar thing to names. So you just use names really, and that's fine. So one of the first things you're going to be doing, just for clarity, so again, for tables, you're going to want to have, or graphs, you're going to want to be having kind of names to variables that make sense, right? You don't want to be having kind of like a bar graph where you've got like, how old are you under one bar, and then what is your gender under another. You want names that are, easy to fit on a graph that easily give you information. So you're going to want to come up with variable names like that. And also just things that are short for you to be writing, particularly, like I said, if you're using kind of long questions, that's just going to be annoying to write into your code when you're doing kind of the data frame, $, variable name. So we can rename the variables. And again, I know this is probably going to look super complicated, right? But it's actually quite simple, right? Because all you're going to need to be doing, so for example, in this, right, you could just, into your work, and I'm giving you this script. So into your own script, you could copy this, paste it in, right? And then replace this with your data frame name, replace this with your data frame name, replace this with your question name that you want to be changing, and replace this with what you want to be calling it. So for example, do you agree? And so I just made up that this do you agree was something about tax cuts. I didn't actually write what the question was about, do you agree? I didn't actually give it more than that because it was just a practice one, but just say it was about do you agree with tax cuts, right? So I called this one tax cut, right? So this way it's nice and short. So if I'm doing kind of the $, type thing, how old are you? I rename that to age. So here again, you'd copy paste it in, you put in whatever your data frame name is, whatever your second question was called, and you put it in quotes again, right? So whatever your second question name is, and then whatever you'd like it to be renamed to. Same, so you could do this for each of your different questions, right? What is the third question name? What do you want it to be named? And is this good? I just called it good. It's easy to remember. So rather than these long, and again, none of my questions were that long, but some of yours are going to be quite long. So this could be, huge benefit to you. So if we run this, right, all of this, and actually rather, you could look ahead to inspect data, but I'm actually going to use instead names. So see now where it used to be timestamp, do you agree? How old are you? What is your race? Is this good? Now timestamp, tax cut, age, race, good. And if we run kind of head, same. Timestamp, tax cut, age, race, good. Makes your life a lot easier. It's shorter, it's more elegant, it's easier to understand, stuff like that. Yeah, easier to be putting in. Same thing, if we click over here, it's all been changed. It's nice. And so that's, again, I know this probably looks like advanced type code, but all you've got to do is copy paste it in and then just change this to whatever your question is, and change it to whatever you want. Whatever you want to be calling it. What do you want the variable name to be? Think of this as the question text, and you're changing it to variable name. If you do it for each of these, you don't even have to remember, you never actually have to write the names, blah, blah, blah part, names, blah, blah, blah part, equals, equals, you'll never have to write, and the assignment. This is essentially just saying that we're changing the names for, if the name for sample data is equal to this, assign it to this instead. That's essentially what we're doing. Sometimes you're going to want to also rename responses. So it may be that the response is too long, or in terms of if you want to be putting it into a graph, one of it was wrong. So say you had a typo in one of your questions or in one of your kind of responses, and you want to be creating a graph with it. Well, you don't want that typo in the graph. So say you've got a bar graph with each of the different possible response options. So strongly agree, and say you had written strongly agree wrong. Well, then you might want to be changing it just to make it look better for your graph. Well, you can easily change the name of a response also. And it's very similar to what we did here, although rather than dealing with names, we're dealing with levels. And rather than just having the data frame name, you need to have the data frame and variable name. So for example, in this one, I had written on all the other ones, I'd written strongly disagree had a small d. Neither agree nor disagree, only the neither had a capitalized first letter. So strongly agree was the only one where the second word was capitalized. So just to make it look nicer and consistent, I changed it. So again, you could copy paste this in. You would need to change your dataset name, your variable name, dataset name, variable name. What is it currently? And what should it be? Right, so then if you run this, you're not going to see anything, but let's see, is there? Yeah, so right now over here, if you had see it strongly agreed capitalized. Now if I do strongly agreed down here is now the agree is no longer capitalized. It's not the, oftentimes this isn't the biggest deal, and so you're not going to have to do this on every variable for sure, but some of them you might have to, so I'm just showing you how to do it. All right, so now we're going to look at kind of how to clean. So that means kind of treat your data to, kind of correct any errors that could be in it, and how to do descriptive stats. And we're going to go by each level of data because you're going to do it differently depending on the level of data. So nominal and interval are going to be quite simple. Ordinal is going to be a little bit more complicated because you can kind of go multiple ways. So let's start with nominal variables. So these are ones that are kind of character type ones, and there's no order to response, right? So for example, race. We can't say one race is above the other or better than the other or higher than the other. It's kind of nonsensical to say, we've got, if it went alphabetic, they're just different categories or jersey numbers, right? Like you couldn't order jersey numbers or telephone numbers, right? There's not one that's above the other, say. There's one that's maybe numerically higher, but that be numerically higher, it can be meaningless. So here they're just different categories. So first thing you might want to be doing is inspect just the variable itself. So we've got string showing it's a factor with 3 levels, black, other, white. So yours might have more. And then it's kind of giving each one numbers based on the level, but that's not that important. And then showing for us at the moment, and then head showing, okay, so these are the first 6 responses, black, white, other, white, black, white. And currently the levels, if we were going to be treating it as ordered, is black, other, white, so just based on alphabetical. That's actually meaningless, so that's something we want to be careful about. But it doesn't really matter if it's there, as long as we don't use any methods and assume it's ordered, we're fine. And so that's just to kind of take a look and make sure that everything's proper. Again, making sure that it is being treated as a factor variable, and what are the different response options, right? So the levels is interesting because it's helpful because it tells us all the different response options. So what we'd want to be doing, so there's 2 different ways that you could kind of do descriptive stats. You could kind of do the number of respondents for each, the one I prefer is percentage of respondents, right? Because say it says, 15 people identified as white. Well, 15 out of how many? Unless somebody knows, there's this many respondents right away, 15 is not that useful. Also, what we really care more is about the share of responses rather than the sum total. So, but let's just start with number of responses first, right? So you do table, and then, so again, this is part you copy is table, and then you just change it to whatever you called your data frame or whatever you called your survey and whatever you called your variable. So in this case, if we're doing it for like the one I've called race, and it gives us, we had 3 black respondents, 1 other, and 4 white. And so if you want to be doing it for any of your nominal ones, right, just change this to, just change the kind of the data set name and the data frame name and the variable name. If you want to be same thing, if you want to be doing percentage, again, you don't have to remember this command. You just copy in my example of it, and then each time you need it, just make sure to update, change this part. So you could copy and paste in this entire line, right? You copy and paste in this entire line into yours, and then just make sure to change this and this. And then just, run it, and you've got it. And so here's showing, okay, so black was 37.5%, other was 12.5%, and white was 50%. So proportions, essentially. Actually, and if you want to be get into proportions, I believe you could do, there is a way to do this. There you go. If you want to have it actually in percentages rather than in kind of proportion, or then you can just add the times 100 at the end, and it'll give you actually in percentage. So if, I mean, it's easy to just manually, for when you're putting into your paper, say, just seeing 0.375, you could easily, when you're writing it, say 37.5%. But if you don't like doing that in your head, you can just do the times 100 and you'll get this. So that's pretty easy. If you want to be doing plots, so you can do plots both of frequencies or relative frequencies. So the relative frequencies would kind of be the percent. So we can use the Barbed Plot command. And so again, most of this, kind of the format, you could just copy paste. And so what you'd want to be just changing is, again, your data frame name and your variable name. And then you'd have to be giving it the X label, so the X-axis label, the Y-axis label, although if you're doing a frequency table, you could just leave frequency, and the title of the graph. Same thing here, we've got the relative frequency one, so you'd need to be changing, again, just data frame name, variable name, so question name, X label, title, and relative frequency you could keep because that would still fit. Personally, I prefer the relative frequency graphs, but you can go with either, that's fine, right? And so let's just run both, and it'll show you the 2 graphs, right? So here's the, hang on, let's start with the first one. So this is the bar graph for just the numbers. So we had 3 select black, 1 select other, 4 select white. And here's the kind of relative frequencies. So kind of in proportion. So 0.5 white, 0.375 black. In R, there's so many things. R is so powerful in terms of graphics. So there's so many customizations you can do, and so many different kind of packages of commands that you could kind of import to do insane graphs. You can change every detail of this graph, from colors to do you have kind of the percentage written here, to the width of this axis line. So many different things you can change, fonts, sizes, but a lot of that gets into more complicated. So I'm just giving you kind of the most basic with the things that you need, right? So I do still want you having axis titles. That's important. And they'd automatically be put just with the variable name too. So we want to give it something nicer, and it wouldn't normally include a title, but we do want that. That's important for a graph to have a title. So I'm just showing you kind of how to do those different things. But again, if you just copy paste this in every time you're doing it for a nominal one, if you just copy paste it in, it'll work. That works pretty nicely. And yeah, so you just copy paste this in each time you're doing it and change the things that need to change. So this you'll need to change, this you'll need to change, and this you'll need to change. But like the whole format of how to write it, that you don't have to change, right? So you don't have to remember bar plot table, you don't have to remember bar plot, parenthesis, prop table, parenthesis table, parenthesis sample. You don't have to remember all those different parentheses and stuff like that. All you got to do is copy paste in kind of the format and then just plug in those things. That's why I talked about earlier why data frame and variable names are so important, and remember to do both. So data frame name, $sign, variable name. All right, so are we doing now ordinal? So ordinals could be the most complicated, partially because ordinal, so always should be treated as categorical, but often in analysis, we treat it as if the numbers are meaningful, right? So we'll calculate kind of the mean response to a Likert scale. Strictly speaking, that's not proper, but it's also easier to interpret. People have a kind of an intuitive understanding of mean. So it makes it kind of just a little bit easier. When you're doing your descriptive stats, you could just stick with the part that I'm going to show you that's similar to what we did for nominal. So kind of just the proportions table. You can kind of ignore for when we're doing the descriptive part, kind of the part where I'm showing you how to turn it into numeric. But once we get into some of the kind of inferential stats, so where you're looking for the relationships, that's where that stuff might become useful, because you might want to be running kind of t-tests or stuff like that with it. It can be really useful. So I'll show you that. So we're going to use tax cut for looking at kind of the data cleaning and the descriptive stats. So remember, this is an ordinal one of kind of like strongly disagree to strongly agree, right? And so if you don't remember kind of the details, we've got, there we go, we've got all of this stuff. So showing factor with 5 levels, agree, disagree, blah, 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 blah. And so kind of to preview one of the things that we're going to need to change is if we look at the order of the levels, it goes agree, disagree, neither disagree nor agree, strongly disagree. Right? That's not the proper order, again, because it just defaults to alphabetical, but that's a weird ordering, right? Normally we'd be thinking of the ordering as being strongly disagree, or strongly disagree, disagree, neither agree nor disagree, agree, strongly agree, or the opposite, strongly agree, all the way over to strongly disagree. Those are kind of the orders that make sense, not the alphabetical here. So what we're going to have to, first step we're going to have to do with ordinal is order the responses. And it's actually quite easy. So we can check the levels, which we saw with head anyway, but we can get it kind of official here. So we can check the levels. And so levels meaning how is it, what order is it being treated? So if we're treating it as ordinal, so where there's an order, what is the order that's been assigned, right? And now we want to change this ordering. So what we're going to be doing is taking the same variable, so it's in data frame sample data, variable name tax cut. So we're not creating a new variable, we're just altering the existing variable. So we're saying treat this variable as factor variable, which it already is treated as a factor, but we're changing the levels, right? So you just have to put in your data frame and your variable name, your data frame and your variable name, and then what is the order that makes sense for you. You do levels. C just means concatenate, or you can think of it as combine. But again, none of this you actually have to write in, because if you copy paste it in, all you've got to be doing is changing this part, and putting kind of your responses into an order that makes sense for you. Again, this could have gone strongly agree through strongly disagree. It doesn't really matter what the order is, just as long as you remember what the order is. So if we do this, so let's run this. And then if we check levels again, now we've got strongly disagree, disagree, neither disagree nor agree, agree, strongly agree. So now it's ordered properly. So yeah, some of this might look scary, but it's actually not so bad. So now we can produce a table, similar we did before, so showing how many people selected each option. So had we not changed the levels, had we not reordered it, right, these wouldn't have gone strongly disagree, disagree, neither agree nor disagree, agree, strongly agree. It would have gone agree, disagree, neither, strongly, which for the table wouldn't have made as easy to read. And again, the prop table. And again, you can do the times 100 if you'd prefer it in percent. Right, so you can do, there you go. And so now we can see what percentage responded to each of these. Now, you could also be calculating the mean. So now it doesn't fully make sense, right? Because the distance between strongly disagree and disagree isn't necessarily the same as disagree and neither agree nor disagree, which isn't necessarily the same as, so the mean is strictly speaking not nonsensical, but we could also kind of understand that, say this is, 1, 2, 3, 4, 5, and we end up with a mean of 1.5. Then we know the average response is somewhere between strongly disagree and disagree, which people can still more or less understand what that means. And it also, the bigger thing is it allows us to use more advanced stats. So again, in descriptive stats, you can just stick with the prop table if you're dealing with ordinal. I'm more including this here because for some of the inferential stats, you may want to be doing regression or t-tests when you're using ordinal. And again, while it's strictly speaking wrong, many publications, people will do it, particularly when you're dealing with Likert scale. So the strongly disagree through strongly agree is quite common to see it done because it's just easy to interpret. It's easy for people to understand. So I'm just going to show you how to do it here. And if you want to be using it later, you can. I'm also always going to show you kind of analysis if you're using ordinal, where you pretty much don't have to do it, or at least in most of the cases where you wouldn't have to do this. So you may not have to do this. This is the most complicated thing we're going to see. But again, so much of it's just going to be you copy paste and then just replace with your stuff. So the first thing you want to do is, this case, we actually do have to create a new variable. Because you don't want to be, you're still going to want to be keeping your original, say, strongly disagree. You're not always going to want to be changing it over to a number. So here we're going to want to create a new variable. So what I often do is I'll just create kind of like the same name. So this one was, the old one was called tax cut. So this one I'm going to call tax cut number, or num, for number, to show that it's still tax cut, but this is the numerical version. This is the original version. And you've got to always still put it in sample data, right? Still put it as kind of a column too. Now, when we do this, we're going to end up with, so let's quickly run this. And then if I do data, print it, we've now got here, see, a new variable tax cut num over here, right? So we've added a column. It's like we've added a question to our data set. Now, we haven't changed the numbers yet because we haven't done anything. All we've essentially told it right now is create a new variable called tax cut numbers that is the same as tax cut. But now that we've done it, we can change these observations to numbers, and this way we'd have both versions. So there's two ways of doing it depending on what your response options are. So this is the version that you can do, replace with numbers. So this is if, so this is how to set up for doing the mean standard deviation if there are no response options like I don't know or prefer not to know. So essentially if all the response options are orderable, right? Because say you had strongly disagree, disagree, neither agree nor disagree, agree, strongly agree, and I don't know. Where does I don't know come in that order? So we're going to have to do something slightly different if we've got those. But say you've just got strongly disagree through strongly agree. So you don't have any I don't know, prefer not to answer, any of that stuff. You can do this. So we've already seen levels, right? We already used that up here when we want to change the response, right? When we want the correct saying, okay, strongly agree. This was supposed to be a lowercase a here. So we're changing that. So we've already used this exact command that we're going to be using over here, but we tell it that, say, for levels, and so our data set, tax cut number, data set variable name, but the number version. When you see strongly agree or strongly disagree, I want to replace it with -2. Now you can, the numbers don't matter so much. So you could do 0 through 4, you could do 1 through 5. When you're dealing though with one where there's a neutral middle, I often like the idea of -2 to say 2, or if it's a 7-point scale, -3 to 3. I like that kind of format because it gives a neutral middle, right? Like you don't have to remember what the middle is. Like say it's 1 through 5. What's the middle? Someone's got to think about, you know, is this showing it's on the disagree or agree side? Or if you go with -2 to 2, if it's negative, it means it's on the disagree side. If it's positive, it means it's on the agree side. But if you want to go with 1 through 5, 0 through 4, it doesn't matter too much. So for each of the different response options, you essentially just want to be correcting what the name is, right? So strongly disagree over to the number. So same as what you had done earlier. So again, you just copy paste in, change this, change this, change this to whatever you need it to be, and change this to whatever you need it to be. And do that for all 5 of the options. Now what happens if you've got I don't know, I prefer not to answer, right? In terms of our ordering, we want to get rid of this. And so, again, we'd start by creating our new variable name, so the copy, so tax cut numbers. And we need a way of telling essentially, don't know, prefer not to answer. As we'd essentially want to be saying that these are missing data. It's as if like the person, rather than they answered I don't know, prefer not to answer, they answered nothing. So just ignore this, treat it as missing, and so when we're looking at it, pretend it doesn't exist. And we do this using what's called an if-else command. Again, this looks scary, but largely if you copy paste it in, it'll work. You just got to keep track. So say yours is 4 or it's 5 or 7. You just got to keep track of making sure you've got enough brackets. But essentially what it's telling you is, so if this is true, so if sample data variable is equal to strongly disagree, replace it with -2, or put in -2 instead. Now when we get to the comma, it's the else part. So if it's equal to strongly disagree, put it to -2. Otherwise, go to the next line. If, and so here we've got kind of a nested if else. So if this is equal to disagree, then put it to -1. Otherwise, go to the next line. If is equal to neither disagree nor disagree, 0. Otherwise, go to the next line. If agree, 1. Otherwise, go to the next line. If equal to strongly agree, 2. Otherwise, go to the next line. Next line is NA. So otherwise, put it as missing. NA is kind of the code for missing, and you see it's blue, so it has kind of meaning as kind of, and that's how we refer to missing values. So this looks, I know, a little bit scarier, but again, this whole template you could copy paste in. Just make sure that if it's yours is more or less than 5, that every time you open parentheses, you've got a closing parentheses. I like using different lines for each of my different closing parentheses and using different lines for each of these so that it's easy. You can count your parentheses. Okay, I open 1, 1, 1, 1, 1, which means that I need to, so I've opened 5 of them, so it means I need to close 1, 2, 3, 4, 5. Otherwise, you're going to end up with kind of errors. And so that's pretty much the only thing to make sure of. And each time you add a line, if you're continuing to another line, make sure there's a comma at the end. So if, say, it were 7, right, I could do this again with another if else, comma, blah, 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 and another one below, if else, comma, right? So all that stuff, comma, blah, 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 another line, da, 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 the 7th one, comma, and then just then end with the NA. And I messed up my, for some reason, when I added all that in. Just give me a second to fix these. Oh, that's why. As if they're not lined up nicely. Yeah, so. Okay, so now we've got it. So now if we do quickly ahead, so now remember tax cut numbers up here had this just the same in words. Now we've got if it's strongly disagree, -2, disagree, -1, strongly agree, 2, neither disagree nor agree, 0. So that's, there we go. That's nice. This would have done the same thing. So if I had run this instead, either we could have used either because there were no, prefer not to answer, I don't know. Most of the cases, you're probably gonna, if it's ordered, you're probably gonna have this, so you're okay. But just in case. Okay, so now how do we get the mean? So first thing you're just gonna wanna do is make sure that it's treating those numbers as numeric. It may be treating them as character. Normally it won't, but it's just a good caution to do that. Just make sure it's doing it as numeric. We can double check. Yeah, so numeric. We can find the mean. And we can find the standard deviation. So again, mean, standard deviation, you could just copy that anytime you want to find the mean, you could just copy this in, put in your data frame name, and your variable name. Data frame name, variable name. And it's commonplace with anything that you do with numeric data that you report both the mean and the standard deviation. So one of the most normal ways of doing it is in terms of doing like so say the mean words, so say, you know, the average or mean age was, you know, 25.2 years, and then like you could do 2.5, something like that. And then kind of end your sentence, right? The average age, so something like that. So because standard deviation is important to know too. So when you're kind of writing your results into your paper. Okay, plots. We'll just use similar, our bar plots. Okay, yeah, so there's a few things we wanted to show. So here's kind of just the normal, like how we've learned it. Now you'll notice if you look down here, at least in the small version, all the labels don't fit. Now, if you get it big enough, they do fit. So it's possible you won't have a problem with this, but depending on how long and how many options you have and how long the text is and stuff like that, you may have a problem. So one thing you can do is you can change the text ordering. So you only do this if when you're, say, copying it in, you run into problems that all the labels aren't fitting. So you could change the orientation. When you do this, you're going to want to drop the X label, though, because otherwise they'll overlap. So that's why you'll see on this one, I don't have an X label. Most of the time when you're copying it into, say, your Word document, it's going to be wide enough that you're not going to have to worry about this. But just in case, this is a way that you can do it. And then again, your relative frequency. There we go. All right, now interval ratio. So this is kind of your numeric one. So think of age, right? So let's take a look. Make sure that it says integer or numeric. If it doesn't, if for some reason it says factor, then just use the numeric command that we had used right here as numeric. Just use that to change it from factor to numeric. Most of the time it'll probably be okay, but just in case. And then, so this is really easy. This is the easiest one. As long as it's already an integer, no preparation, you could go right into the mean, the standard deviation, the median, or the range. So the range could be useful, for example, say you're talking about age. You might want to say like, you know, the mean age was this, with the youngest person being 18 and the oldest person being 73. So mean, standard deviation with the min max, right? And so range, you could also do min or max. Right, so you could do min sample data age, but I mean, might as well do range where you get both of them. Just save a little bit of writing. So all these, yeah, all of them. So your median age that I wrote was 35.3, the standard deviation 14, median, so on and so forth. So that's quite easy. And then you could just do a histogram. So put in the, again, just copy in and do your data frame name, variable name, x-axis label, y-axis label. This one you don't have to change. This one you'll have to change, and title, respondent ages. So that's pretty easy. So now we're getting into data analysis, so this is the final section. The most important in terms of actually being able to do the analysis. Most of the other part is just straight reporting. You may still want to do there's no real analysis to do on kind of the demographics, or there may sometimes be some analysis. You're going to want to talk about, like, say, everybody in your survey saying agree or strongly agree. You're probably going to want to talk about that a little bit, because that's still interesting. It's not part of one of your hypotheses, but it's still interesting to potentially discuss a little bit. But here is when we're getting into the real analysis of the inferential statistics, right? This is where you're going to really want to be talking about, like, does this fit your assumptions? And so I break down the inferential statistics based on what your independent variable is and your dependent variable, right? So I'll say if it's nominal or ordinal independent variable with a nominal or ordinal dependent variable, these are your options. You're going to notice that when it's ordinal, because we can treat it as both categorical, but we can also kind of treat it as numeric. Ordinal actually kind of goes into each of them. So you've got multiple choices when you're dealing with ordinal data. With pretty much all the others, you've got less choice. So if they're both nominal or ordinal, and this is actually going to be the case for most of your questions, because a lot of them are, many of your questions are ordinal, kind of the strongly agree to strongly disagree, or you kind of choose, or nominal where there's no order. You'll have some of the demographics where they insert like a number where it's interval, but that's a lot more rare. So most of them that you're actually going to be dealing with are nominal or ordinal. So this could be the most common. So you can use the chi-square test of independence. Those of you who took QM with me, we didn't get to that because of the short semester. I don't know those who took QM with anyone else, if you managed to still get the chi-square. I'm going to post slides from another year I taught QM about chi-square. But essentially, the chi-square test, it tests the null hypothesis that the two variables are independent. If the p-value is less than 0.05, less than 0.05, we can reject the null hypothesis of the independence and conclude that the two variables are dependent related. So essentially what it does is it creates kind of a contingency table. So it looks at like the number of people, say we have like race and did you respond yes or no to good, right? So I'll take the number of people who said yes to who are white and said yes, the number of people who are black who said yes, the number of people who respond other who said yes, the number of people who were white who said no. And so it's going to look at first, what's the expected value if the null hypothesis is right and it's independent? So what's the expected value just based on, based on random chance? So if there's no relationship, you would expect it just to be proportional, right? So say 25% of the people are white, you'd expect, or half of them to say yes, half of them to say no. And so you'd expect then 12.5%, or let's say it goes 50 to make the math easier. Say 50% of the people are white, right? You'd expect, if there's no relationship, you'd expect just by chance 25% of them to say, about 25% of them to say yes, about 25% of them to say no, half, right? Because if there's no relationship, there shouldn't be any pattern. So that's kind of, and then it looks at, so that's kind of the expected if there's no relationship. And then it looks at what's the actual observed. So is it, 35% say yes and 15% say no? Well, and then based on that, it calculates, what's the probability of that? And so what's the kind of, is there a, it uses what's called the chi-square distribution to see, can we conclude that these are independent null hypothesis, or do they appear to be dependent, right? Based on how far the observations are from just chance, how likely is it that there's a relationship? And if it's a small p-value, it means that there's likely a relationship. So if it's less than 0.05, then we could kind of reject the null hypothesis that there's no relationship. So there's two steps for doing this. First thing you have to do is create a contingency table. So those are tables I told you about before. So you've got to give it a name. So like I usually just do kind of the two variable names and then like a table. And you do this, right? So you create if you follow that template, variable 1, variable 2, so independent variable, dependent variable, table, and then put in your 2 variables. So let's just show you what a contingency table looks like, right? So the 3 kind of options for race, and the numbers like kind of gave no and yes. And then using that table, we we do the chi-square test. Ignore this error message, it's normal. So if your sample size is too small, you're likely to get this saying that it could be wrong. That's okay, just ignore that. And hopefully your sample sizes are big enough. But if you get this warning message, don't worry about it. Now, in this output, the 2 most important things are what is the chi-square statistic, but actually the single most important one is what's the p-value, right? And so you could get this output and pull them out, but if you also want to get them where you can print them, so I also name the chi-square output, so like race, variable 1, variable 2, and you could use like chi, or you could do chi2, and save the kind of the output, and then kind of then name it and give, here's the p-value, here's the statistic. So it's just pulling from this, right? It's pulling out the stats that you want. The p-value is the most important one, but the chi-square you're also going to want to be reporting. For plot, there's not a good plot that's easy to do. There are kind of versions of graphical contingency tables that you can do in R. They're really pretty, but they're also require more advanced kind of data or more advanced packages and commands. So for you, just create a table in your text that looks like the contingency table. So take this table or take these numbers, right, and put them into a table in your Word document, and that'll be fine for kind of a graphic. Use a table instead of a graph, and that's fine. So that's the first set. This is going to be a lot of yours. I'm not actually personally a huge fan of chi-square tests, but they're simple to run, and so a lot of yours are going to end up being chi-square tests, and that's okay. With surveys, that's not unusual. If you've got a nominal independent variable with ordinal, interval, or ratio dependent variable. So this will often be the case if you're doing a survey experiment, but it also could be, for example, say you did, like your independent variable is gender, right? And then you've got ordinal, interval, or ratio dependent variable. Now note, if the dependent variable is ordinal, you can still do your chi-square test, right? Because with nominal and ordinal, you also fit here. So you could do either one of, in this case, you could do either one of them. But if you have nominal with ordinal, you also have this choice. So if, for example, you've got race or gender as your independent variable with any of these, you can do comparisons of means, so t-tests. Let's look at, we're going to do a couple of examples. So let's do one where we're comparing white with all other respondents, right? Because there are ways of comparing multiple groups, so comparing, say, a white to black to other all at the same time, but they're a little bit more complicated, and I doubt any of you with the shorter semester had time in QM to get to ANOVAs, and they're a little bit more complex, so we're just going to do kind of single comparison of means. So for the first one we're going to do, we're doing a test of race, but we're comparing white to all others. And this, you're going to say you're doing this, you'd have to do probably race, white versus all others, black versus all others, depending on what you think is important, right? If it's racism, you might care kind of white versus others, white being the dominant group versus others. It depends on your theory. And we're doing predictor of agreements with tax cuts. So the first thing we've got to do is we've got to create separate data sets for each of our, for kind of our 2 different groups, right? So say we've got white and non-white, right? We need to create a data set just for white respondents, and we need to create a data set for non-white respondents. So here we're creating, so this is, rather than creating a new variable, we're creating a whole new data set, because then we're going to compare the response in these 2 data sets. So let's call the one for white respondents, we can call it sample data white. And we're just saying, so we're taking it from sample data. So kind of reproduce the sample data set if the sample data race variable is equal to white. So again, just if you're doing in your case, copy paste it in. And so this way you don't have to worry about all the different brackets and quotes and commas and stuff like that. Just remember, okay, so here you put what your original data frame name is, kind of how you need to be changing it, your original data frame name, the variable that you care about, and kind of the characteristic or the attribute it takes. And then we do the same for non-white. So sample data non-white, same thing. But rather than saying is equal to white, in this case, we're saying everybody else, we do is not equal to. And so exclamation point equals is the version for not equal to white. So you could also write this sample data non-white is equal to sample data race is equal to black, or sample data race is equal to other. So this, the vertical line means or. That would work fine too. Oftentimes this is kind of the version you'd have to do. But for us, this would also work too. So either of those would do the same thing. So let's create those two. So now you'll see we've got two other data sets that were created. We've got sample data non-white, sample data white. Each of them have 4 observations because there was 4 white and 4 non-white. And it's still the same number of variables. Then to do the t-test, so we could call it t-test race tax, so the 2 variables. And then what we do is we compare the tax cut, the kind of the average tax cut response for both of them. So we use the t-test command. So we do sample data, dataset 1 with the variable, sample data, dataset 2 with the same variable, and we're comparing them. Now it's important here, this is where I said kind of the numeric, you need to use the numeric version of tax cut number, so the one that was -2 to 2. So that's where I said when kind of what we did up here may come into play a little bit more with the inferential stats. So that's where that may come into play more, because you need the numeric version here, because you couldn't be comparing average if it was strongly disagreed, that just wouldn't work. So if we do this, and then, so we give it a name, and then there's a few different things that we might care about, right? We might care about the p-value. We might care about the confidence interval. And we might care about the estimate. So what were the mean of both of them? So the mean of the first one was -1. So for white was -1. For non-white was 0, right? So the way you'd sometimes write this up in terms of your analysis would be like, say, the difference in, let's put it, of one is statistically significant. P is equal to, let's see, P was equal to 0.37. So it's above 0.5, so it's not statistically significant. Or say it had been statistically significant, you could say is statistically significant, p less than 0.05 you could do, say, or less than 0.05 you put at which level, or you could just do p is equal to 0.0437. This isn't what it is, I'm just making up those numbers, but that's how you could kind of write it. So the difference in the mean of 1, so you've got mean of -1 here. So the difference of 1 between them, and report whether it's statistically significant. So that's kind of how you'd write up those. All right. How do we plot it? So there's much more elegant ways to do this, but with simple things that we can do to not kind of overwhelm you, what you could just do is create 2 side-by-side bar plots. To do a bar plot for, so both of them kind of doing tax cut. And in this case, because it's a bar plot, you won't want to use a number version. You just want to use the, oops, why do I have it? Good. All right. All right, sorry about that. All right, so we just use our normal bar plot one, still with just tax cut variable, not text cut num, because we're using bar plots, and so we don't need the numbers, we want the labels. So just like you've done before, but rather than using the full data set, one of them you'd use just the white respondent, so your white data set, the other your non-white data set. So you could print. And so you could put them beside each other in the table, right? So here's the non-white, here's the white. And so you could put these beside each other and look and see just visually, do they look different, right? Like, so in this case, say these were your results. They look pretty different. So it looks like there's a different pattern here. So it looks like there's some relationship. We didn't find it with p-value because there's only like 8 respondents, but it looks like there's a relationship if you had that. So you could put them side by side and that kind of gives you a visual representation. There's nicer ways of doing it, but that's okay. Another example, so this was kind of dealing with nominal with ordinal. Here's nominal with interval. So this is a simpler example. So to come up with an example of the ones I had, we had to go with race as predictor of age. I know that's nonsensical. Race can't predict age, but just for showing you how to kind of set it up. We do a comparison of age. So this time we're doing white versus black, just to show you another way of kind of setting it up, other ways of kind of creating subsets. This is called creating subsets, subsets of your data set, right? So your full data set includes everything. Your subset, this subset includes just white respondents. This subset includes just black respondents. So similar to what we did before, sample data white, sample data, your original data set variable is equal to white. And so this is your new data set name, your other new data set equal to black. So let's just do that. Okay. Now we do a t-test. we don't have to worry about changing anything over using number version because age is already numeric. So we take just sample data white, the age, sample data black, the age, and compare them. And then again, you can get the p-value, the confidence interval, and the estimate. Plotting it, you could do side-by-side histograms. This really, again, isn't ideal, particularly because the histogram is gonna kind of have different bin sizes, which is a little bit unfortunate. But I don't want to overwhelm with too much information on graphs. So we're going to stick with the pretty basic ones, and that's okay. And finally, if you've got ordinal, interval, or ratio independent variable with ordinal, interval, or ratio dependent variable, you can do a OLS regression, so an ordinary least square regression. If you didn't get to that in your QM class, I'll post again slides. Those who took QM with me, we did get to this, but I don't know if everybody, all the different QM classes did. So if not, I'm going to post slides on it. Again, if the independent and dependent variable are both ordinal, you can also use the chi-square test. So if you're not as comfortable with this, and so in many of the cases, you are going to be dealing with two ordinal. So if you're dealing with two ordinal, you could do the chi-square, or you could do this. If you're doing this, so each time, remember you're going to have to be using the numeric version. So you're going to have to be transforming it into some form of numeric version. So like how we created the tax cut numbers. So this is the format for using, for doing a least squares regression. So first we name the output. This is important to do. So again, I use kind of variable 1, variable 2, so kind of predictor variable, dependent variable, and then I just give it because we're doing a linear model, just to remember that this is the linear model. And then, so then you could copy paste this in and just be putting your variable name, and again, always updating your data set name. So I'm doing, in this case, we're doing age as predictor of tax cuts. So the important thing to remember here, and that's why I even put it in kind of the notes, is it goes dependent variable, then independent variable. So think of it as an equation. So this would be like y is equal to x plus, and then it could be x2, x3, x4, x5. So this would be y is equal to x. So x in your independent variable. So if we do this. Now, I know this output kind of sucks a little bit. There's a lot of stuff here. There's not too much you need to be paying attention to. You need to be paying attention to a little bit the estimate column. So the estimate is, so if you're thinking of making like a best fit line, so if you're trying to fit a line to kind of your scatter plot, this is the coefficients that would go into your kind of y is equal to mx plus b equation. These are the coefficients. So kind of your, so you've got your y-intercept and your slope coefficient. The bigger thing to be paying attention to is, are there stars beside this, in particular this one? If there's star, it means that that variable is statistically significant. And I'll kind of give you below kind of the details on, because none of them are, it doesn't really tell you, but they'll give you kind of the details on at what level. But if they're stars, then it means statistically significant. So I'd look for what are the slope estimates, so y-intercept and slope estimate. Is it statistically significant? So you can see in this case, it's not statistically. You don't even have to necessarily look at the star, because you can also see the probability. So in this case, the p-value is 732, clearly not statistically significant. But if it's less than 0.05, so look at this, and then look at r squared, which is the percentage of explained variance. The closer it is to 1, the stronger the relationship between them. The closer it is to zero, or if it is zero, there's no relationship, right? So, because this is the percentage of variance in your dependent variable that's explained by the independent variable. So in this case, only 2% is explained, which is very, very low. So those are the things that you look at. Would be this, but actually a little bit less. We'll really be looking at this and this. Those are the things that you'd want to be reporting. So if you're describing that relationship, say, not based on the linear regression, it's not statistically significant, or it is statistically significant with the p-value, and say based on the r-squared variable, 23% or 33% of variance is explained by the independent variable, something like that. So kind of those are the things that you want to be looking at. And that's what one thing to look in surveys that I kind of posted, to get a little bit of the language that people use. But those are the two things I kind of want you to be reporting on when you're discussing your results. Is I'd want to comment on this, and I'd want to comment on this. To put a plot, so we essentially do a scatter plot with a best fit line. So this is the regression line. So these essentially, that line is done using these coefficients, are made using those coefficients. So for example, the y-intercept is 0.0057. Which actually doesn't look like there, but it might be just slightly off. Or actually no, because that's not actually we're 0. So okay. So here we've got a scatter plot of age and support, and support protected by age, and we fit kind of a best fit line. So this is kind of our prediction line, right? So if we want, say we found out someone's 30 years old, what would we predict their support would be? And so we predict that their support would be this. As you can see here, though, that the prediction is not necessarily so good, because it looks kind of like a bit of a cloud around it. So it doesn't really look like a very strong relationship. So we won't be confident our prediction's right, but it would be our best prediction we could make. So how do we do this? So it's similar, as simple. We do kind of plot our two variables. So variable 1, variable 2. So kind of our independent variable or dependent variable. We need an X label, we need a Y label, we need a title like normal. So this is just like making a plot. So similar to most of the other plots we've made, just there's now two variables. And then AB line is just telling it the fitted line. And what line are we fitting? We're fitting the best, we're fitting the regression line. And so we're pointing to the regression output. So whatever we called our, that's why I said it's important to name our regression output, because we're going to be needing it both to get kind of the summary, and we're going to be needing it for making the plot over here. So both of those are important. And so that's pretty much everything that you need. That should be all the different types of relationships you need to look at, right? So we've gone through kind of the basics of based on how Google Forms is outputting the data to the CSV, right? We looked at some of the things you might need to do to make it more usable, right? So you may need to change variable names. You may need to rename some response options, right? Then you're gonna have to do descriptive stats for both your demographics, but also for your independent and dependent variables. So we've broken it down based on whether it's nominal, ordinal, or interval ratio. And again, for the descriptive stats, really don't worry about the mean part if it's ordinal. Don't worry about that part. Just give me the proportions. really only save this part if you want to be doing kind of the t-test or the regression with the ordinal. That's really the only place where this will come in. If it's just the descriptive stats, just give me the proportions. Save yourself the headache. Only do it if you don't want to be doing the chi-square test. Particularly, it's nice, like if you could be doing the t-test, say comparing male, female, or something like that. That would be really useful. A t-test is really nice in these cases. So particularly if it's, you've got to continue at an interval level dependent variable, but you've got a nominal, or say you've got an ordinal level dependent variable with a nominal independent variable. In that case, it might be really nice to do the t-test. So there you might have to do this for the ordinal one, but other than that, don't worry too much about it. The plots for the appendices, your interval, these are going to be kind of your age ones. These are your simplest ones. And then the analysis. And then, so it's going to depend on your independent variable and your dependent variable. Also remember, if it's ordinal, if either variable is ordinal, there may be more than one option. So if both of them are ordinal, you've got more than one option, right? Because remembering that ordinal can kind of be treated as if it's numeric and as if it's categorical. So you've got more than one option. So nominal, ordinal, nominal with either ordinal interval ratio and ordinal interval ratio with ordinal interval ratio. So there's a lot of different options sometimes when you've got ordinal. So you can choose so in many of your cases, you may end up just doing the chi-square test with a lot of them. And that's okay, because just remembering your survey questions, a lot of them are nominal and ordinal. So if you just kind of get comfortable for most of them, just doing chi-square tests, and that's kind of how you do it for most of them, that's perfectly fine. There's a few where you may have kind of interval or stuff like that, but that's totally fine if you stick largely to chi-square. That doesn't bother me. All right, so if you have any questions, don't forget you're working on this in groups, so you can figure it out together. Remember that I've given you pretty much all the code that you need. So pretty much most of it is, I've given you all the commands you need. So most of it's just going to end up being replacing stuff. So kind of putting in, like in this type of code, right? Give it your appropriate, so change this to your independent variable, change this to your dependent variable, change this to your data frame name, to your variable name, to your data frame name, to your variable name. So a lot of it just could be copy, paste, and then just replace with your data frame name and with your variable name. So don't panic, and you can keep multiple scripts open. So when I'm doing something, I often keep like the last version that I had done, and I flip back and forth between kind of my most recent study where I've done this. So, I've been using R for years, and I don't remember most of all the command structures and stuff like that, but I just cheat off of what I did the last time. So it's fine if you cheat off this and just, okay, I need to do a regression here. Let's copy this in. I need to do a plot for regression. Let's copy this in and just replace the variable names and the data frame names. That's largely what your R experience is going to be doing. So you've just got to figure out, what is my level of data, right? Based on my level of data, which descriptive stat do I need and which inferential stat do I need? And then just kind of copy the code in for it and copy the code in and, replace the variable.